Good morning, everybody. Thank you for taking the time to join us today. We're going to talk about rethinking drone design. It's a project that was brought together by the DuPont Silicon Valley Technology Center team and 219 Design. My name is Julian Velazquez, and I lead our innovation and design efforts out at the Silicon Valley Innovation Center. Miguel, would you like to introduce yourself?
My name is Miguel Piedrahita. I'm one of the founding partners at 219 Design, which is an interdisciplinary engineering firm, and we partnered with DuPont on this project.
Great. So let's get this started. So a little bit about DuPont first. We've been around for over 2 centuries, which is quite a lot, especially out here in the Silicon Valley. Um, DuPont really has a focus on transforming the world and solving our most pressing issues through the world of science and engineering. We pride ourselves as being people that are innovators, doers, but really above all, we're problem solvers. We're located in over 70 countries. We have over 35,000 colleagues, 250 manufacturing sites, and over 10 global R&D centers. Now, this story really takes place out in Silicon Valley, in our technology center. We've been around for about 2 years, and this story that we'll tell you in a few really took place in about 5 months. So a little bit about our site. The Silicon Valley Technology Center is a place where we as DuPont can really drive value for our customers, partners, and startups. We focus on an open innovation system approach to bring in new business and product development. Our customers and partners can experience working hand in hand with DuPont, with our material portfolio, and have real access to our expertise and knowledge. We also use the site to rapidly develop prototypes. Using our materials, we really, again, try to address system level challenges and really try to enable leading edge hardware design that will end up in customer products. So on our product portfolio, the Silicon Valley Technology Center focuses mainly on electronics and imaging. We are the world's largest supplier with a broad set of materials for technologies that solve really complex problems, mainly focusing around the semiconductor, circuit board, photovoltaic display, and printing industries. However, we also support different parts of our material portfolio, things that fall under our transportation and advanced polymers categories, as well as safety and construction. Now, you'll see a lot of the materials and processes that fall under these categories, these industries, in the drone that we will reveal soon. Now, inside the Silicon Valley Technology Center, we have several labs. We're currently under construction, so there will be more coming. But currently, we have labs dedicated to characterization, reliability, formulation, RF technologies, and fabrication. We have a highly skilled rotating selection of technical engineers that are always available for rapid prototyping. As a matter of fact, we pride ourselves as trying to bring out prototypes and proof of concepts in as little as 24 hours. So I guess we should start off at the beginning of the story here. So during its conception, the SVTC, which is Silicon Valley Technology Center, we really needed to create a highly engaging, interactive prototype, several prototypes actually. But we wanted to make sure that these prototypes demonstrated our materials and our capabilities. We only, again, had about 5 months to complete this project. So we partnered with 219 Design. Why don't I go ahead and Miguel, have you talk a little bit about 219 Design?
Yeah, so 219 Design is a Silicon Valley-based product engineering consultancy. We're a pretty broad firm. Our expertise spans mechanical, electronics, software, and firmware engineering. And you can see a little snapshot of our team there. And on the next slide, we've been in business for about 16 years. We have over 20 engineers on staff, and over the years we've completed over 500 projects for a variety of clients such as Google, Oris, Surgical Robotics, BMW, ABB, and many others. And here you can see some snapshots of some of the projects we've done over the years. So when DuPont approached us with this idea of, hey, what can we develop in terms of a prototype that would really demonstrate the capabilities of DuPont's materials and technologies, we really started from the ground up and considered a number of different concepts, ultimately landing on a drone, which we realized could really check those boxes in terms of something that was engaging to look at, people would understand quickly, and really demonstrated the advantages of those DuPont materials. So here are some early sketches that we put together as we were starting to get a design direction in mind for the general look and feel of the drone, while in parallel we were looking at the technological aspects of how to incorporate different materials in beneficial ways. And as we moved forward, here are some steps further along the process as we were moving from design to fabrication and production. So on the top left, you can see some 3D printing going on for the flexible landing pads. And Julian, if you want to speak to some of the other steps that we're looking at here.
Yeah, so, you know, I guess this would be a good time to also talk a little bit about how we work together as two organizations. Really, the collaboration efforts between the two were quite a sight to see. There was clearly a lot of pressure coming in from the short amount of time to create a product from concept all the way to actual working product, like you'll see in a few. The teams really put their heads together, and we came up with a lot of unique designs and a lot of interesting ways to put together a drone. So like Miguel said, if you see in the top right, top left there, those are landing pads made out of Hytrel. You'll see them in a little bit more detail, but the thought process behind this, these landing pads, is really something to be impressed by. We took a lot of influence from insects and paraplegics to really come up with a quite unique way of landing a drone. But the other part of this was coming together as two teams with the knowledge and expertise that we have at DuPont. 219 was able to learn a lot about the different materials in our portfolio and put them to use in ways that we didn't think were possible, and definitely have struck a bell with a lot of our customers and visitors. So here it is. This was the final product and what is now living in our innovation center out in the Silicon Valley Technology Center. As you can see here, it's a very different looking kind of drone. And it does fly. We'll show you in a few. But as you can see here, it does not look like anything else out in the market. And that was with intent. We really wanted to highlight our materials in different ways and make sure that when you walked in, it really did grab your attention. Okay, Miguel, would you like to maybe go over some of the materials we used here?
Yeah, let me touch on a couple of these. So starting at the top left, just want to point out some of the interesting features here. So there's a canopy that you can see there that's housing the electronics and the battery and so forth. And on the walls of that canopy, we actually used a DuPont conductive ink and as well as conductive epoxies to integrate the antennas for the drone as well as LEDs directly onto that canopy. So it's a pretty cool process where you print the electronics, the electronic traces, and then thermoform the plastic, giving that nice curved shape with traces directly on the part. That was a really cool way of reducing the wiring complexity and the weight. So compared to traditional wiring techniques, we saw some really nice advantages. And the other one I might mention is on the top right, the frame. The drone's frame is made out of Zytel, which is a high performance nylon. And it was really kind of the perfect material for this application due to its toughness, strength, and lightweight features. So again, just kind of check some really nice boxes and improve the performance of the drone over traditional engineering materials.
Yeah, and I'll touch on a few more here. So the landing gear, as I mentioned before, we really took some time on figuring out what would be the best way to showcase the durability and flexibility of Hytrel, which is a 3D printed material. And we came up with this design of sort of like an insect's leg, where the impact of the drone landing will be absorbed right onto the landing gears and will also sort of propel the drone upwards when it's taking off. So a very unique design and a really nice way to just demonstrate how durable and flexible Hytrel is. And I believe lastly, we have the battery warmer here. So very cool story. When we were first learning about drones and in this case, hobby droning, if that's even a word, we learned that a lot of the batteries that are inside of these um, drones are not thermally regulated, meaning that they do require some sort of heat regulation in order to have the appropriate power to power the drone and to take off. So a lot of these hobbyists will come up with interesting ways to heat up the battery. Some will put the battery underneath their armpit and give it a few seconds or a minute or two to heat up and then plug it right back in. And we thought, well, we don't want to really seem like fools with batteries on their armpits. So what can we do? This ended up becoming a really great story and a really great collaboration situation where multiple DuPont engineers and scientists sat with 219 Design and came up with this idea of wrapping Kapton RS, which is a thin heat warmer in between the cells of the battery pack, and then adhering it with some Temprion, and then rewiring it back into the drone. This gave us a really lightweight and a very cost-effective way of thermally regulating the battery heat. So a very interesting process and a very interesting approach to something as trivial as a battery. Here's a quick demonstration. This was actually one of the first flights of the drone, so we'll go ahead and get this started. All right, so why don't we kick off our Q&A session now? Do we have any questions on the Q&A?
We've had an individual that would like to learn more about DuPont and if you're accepting visitors at the Innovation Center and how that visit can be arranged.
Yeah, so currently, because of obvious reasons, we are not accepting visitors physically. However, we are accepting visitors virtually. The team has set up a way for you to have a virtual walkthrough of the Innovation Center. And if you're more interested in doing so, please reach out to us directly. We'll send out an email so that you can let us know your interest, and we'd be happy to host you in a virtual setting. We do anticipate to eventually start to let small groups in, but at the moment we only offer a virtual tour.
Thanks, Julian. We have another question come in. How has the drone been received?
I think we could both answer this one here. So really well. For one, it's always an eye catcher. Usually when people walk into the center, that's the first thing that catches their eyes, and they'll gravitate right towards. But Miguel and I have actually hosted this exact presentation at ID TechX conference out in San Jose. And I gotta say, we were probably some of the most popular people there after the presentation. What did you say, Miguel?
Yeah, definitely. People really seem to engage with this drone. I think, it's it's got a kind of a novel look to it, kind of an interesting look, and then of course when they learn about what's going on under the hood, I think, even more so. So, yeah, we've found that people were really, really psyched to talk to us after the presentation and come and check out the drone in person. So, I think it really has been successful in that respect for sure.
Yeah, and I will say it's really shown. It's a testament to 219's capabilities. They've been really great to work with, and again, it's just another really great way to show a lot of our materials working together as one. Do we have any more?
We do. Why did you choose these materials to create the drone?
So I think we could both answer this one as well. So I'll take a stab first here. So it's for multiple reasons. One, there was obvious, intent on trying to use some of these materials, not just because they were the best for this scenario, but also because we wanted to bring in as much of our portfolio as possible. A lot of it also came down to the design. So for example, the flex cable that was used around the frame, aesthetically, putting wires there wouldn't have looked great, but also for lightweight purposes, and to really showcase how our materials can be used in sort of these novel ways. It also came down to availability. Working at such a tight time frame really did put our teams and our distribution teams up to the challenge, and I think we did pretty well. Miguel,
Yeah.
would you like to add anything?
Yeah, I think the other thing I would add is, just from an engineering perspective, it was pretty interesting, pretty eye-opening to work with the DuPont team. Like Julian said, they have excellent applications engineering resources locally in the Silicon Valley Technology Center. So having those resources was really key because from an engineering perspective, you see this huge suite of, huge portfolio of materials. It can be a little bit difficult to, really find the right ones. So that was really beneficial to be able to talk to those experts, and they steered us in the right direction and helped us connect the dots like, oh, this material would allow us to do X, Y, and Z with the drone. Like, for example, the flexible landing gear that Julian mentioned earlier. That was like a real aha moment when we realized it had the toughness we needed as well as the flexibility and could be 3D printed. Like, that's a really unique set of characteristics. So it was really, again, just really helpful to get that help to find the sweet spot of materials for the different parts of the drone.
So can you discuss the benefits of 3D printing brought to the process?
Yeah, maybe I can speak to that. So one of the things that's fantastic about 3D printing in general is that it really speeds up the design cycle when we're able to do 3D printing in-house. And all of the 3D printable materials that we used in this drone can be printed using common extrusion style printers. So it was really nice to be able to turn around a part in 24 hours or less, make quick change, do some testing, make some quick changes, and then repeat the print. So that was the big benefit. And then of course, the nice thing about these materials in particular is you can then move the exact same part into an injection molded tooling and get some injection molded parts using the same material. So you're really testing your 3D prints based on the final material that you would use in higher volume production. So that was fantastic to kind of have to be able to gain that confidence before spending money on tooling.
Any more, Nancy?
Nope, no additional questions.
All right then. Well, thank you, everybody. We really enjoy the questions, and we hope that you enjoyed our presentation. That concludes today's webinar. Please feel free to reach out to both of us if you'd like to know more or perhaps work together. Take care.